The Sun is always active. It influences the environment around the Earth and other planets, and it also generates changes in space for the entire solar system, something we call space weather. We feel its effects on Earth in many ways, and once we leave our protective atmosphere, it affects our satellites, robotic missions, and human explorers to nations. But what causes the Sun to vary so much? A closer look at its structure may reveal the answer. Studying the magnetic field and surface activity such as sunspots, solar flares, and coronal mass ejections may provide vital clues. As NASA works to reach its science objectives, it will gather pieces of the puzzle that will unlock the Sun's inner secrets. This will give us a clearer picture of the Sun than ever before, and what we will see will give us new understanding of what drives it. But the most important result of NASA's heliophysics research is how it applies to our daily lives. Satellite and ground communications, aircraft navigation systems, and power grids can all be affected by solar activity.
Space-based observatories provide us with a unique view of solar activity. In 2006, NASA launched twin state-of-the-art satellites to study at close hand solar storms and sunspots, visible signs of deep magnetic activity that affects the whole solar system. The scientists borrow a trick from 1950s B-movies to create a 3D image of the Sun. They deployed two satellites orbiting in tandem, one in front of the other, so they can build a three-dimensional image back on Earth. This 3D image will provide crucial new data on massive explosions of electrified plasma called solar storms. Billions of tons of superheated gas fly into space and buffet the Earth's atmosphere, creating the most dramatic northern and southern lights. Michael Kaiser of the Solar Terrestrial Relations Observatory, or STEREO.
We want to monitor these storms so that we can better predict them. These storms are basically electrical storms, and they can affect spacecraft, ground power systems. The GPS can be upset.
Solar storms are caused by lines of magnetic force ripping through the Sun's gaseous surface and snapping, spewing out hot gases and a fierce stream of charged particles, the most powerful type of what's called solar wind. Some storms take 2 days to strike the Earth, while very large ejections arrive in only 12 hours.